Dear students, in this video we are going to see 2.3, 2.4, 2.5. Already we know that what is the definition for continuous and what is the definition for derivative, because this we studied in calculus 1. Now here you see, suppose the complex function w is equal to f of z is equal to u plus iv is differentiable at z equal to z naught. Then we have to check whether u and v satisfy the CR equations at z naught. If it satisfies, then we can say that w is equal to f of z is analytic, that is differentiable at this point z equal to z naught. Okay, what is CR equations? This is the condition for CR equations, that is dou u by dou x, that is partial derivative with respect to x of u here is equal to partial derivative of b with respect to y, and these two must be equal, that is ux. See, ux equal to by, and another condition, that is dou u by dou y is equal to minus dou v by dou x, that is another condition. Okay, either you can write in this form or you can write in this form. This is called CR equations. If a complex function satisfies CR equations at that particular point, then we can say that the complex function is differentiable at that point. Okay, now what is analytic? A complex valued function f of z is said to be analytic on an open set G if it has derivative at every point of G. Analytic means that given complex valued function should be derivative at every point. Then we can say that that is analytic. Otherwise we can say that that is analytic everywhere. Okay, so now we'll see here, for each of the following determine the points at which the function is not analytic. Okay, for example, you see this function is a complex value function, that is f of z is equal to 1 divided by z minus 2 plus 3i. Here the question is that at which point the function is not analytic. For that, what you have to do, you consider the denominator, that is z minus 2 plus 3i. Consider the denominator, put denominator value is equal to 0, then you find the value of z. Okay, that is nothing but z is equal to 2 minus 3i at this point, because this is the value of z from the denominator what you have got. So now at z equal to 2 minus 3i, this function is not analytic. Similarly, you can find the value of the value of z from the denominator. That points are called not analytic points for the given function. Okay, now you see here about analytic. Here check the following functions are analytic. Okay, now you see the first example. Now what is the given function? F of z is equal to z. Z means x plus I bar. This is a Cartesian form. Here what is u? U is x. What is b? B is y. Okay, now what we have to check, whether the given functions are analytic or not analytic. Okay, now what is the condition for analytic? We know that ux equal to by, uy is equal to minus bx, that is dou u by dou x. Dou u by dou x, you have to find the partial derivative of u with respect to x. What is u? U is equal to x. You differentiate with respect to x, you will get 1. Okay, now similarly you differentiate b. B is y. You differentiate b partially with respect to y. What is the answer? 1. So that ux is equal to by. So here the first equation of CR condition is satisfied. Okay, similarly we have to find dou u by dou y. That is the second condition for CR equations. So now you differentiate u with respect to y, so it will become 0. Now here you differentiate b with respect to x, that is also 0. So now dou u by dou y is equal to 0. This equal to minus dou v by dou x. This is the second condition for CR equation. So now both the conditions satisfied for this given function. So that we can say that this function f of z is equal to z is analytic everywhere, because this function satisfies the CR conditions. So we can say that it is analytic. Now we see example 2. that is given function is equal to z star. Z star, here the notation is something different, but we used to say z bar is nothing but a complex conjugate of z equal to x plus iy. So now z bar is nothing but z star, okay, is equal to x plus iy whole star, that is z bar. Okay, so now what is the complex conjugate? You have to change the sign of I. So now x plus I, here you see we have changed the sign of the imaginary part, so minus y. So now this is the given function, this is the given function, that is z bar. Okay, that is given here, z bar, okay, or z star. Okay, now what is u in this function? U is x. What is v? That is minus y. What we have to check? We have to check whether this given function is analytic or not analytic. So for that we have to check the CR equations. Okay, now what is CR equation? First one is ux is equal to vy, second one is uy is equal to minus vx. Okay, so now ux means what? You take the partial derivative of u with respect to x. Now you see partial derivative of u with respect to x, that is 1. See here, because u is equal to x. Okay, now what is dou v by dou y? That is by, partial derivative of b with respect to y, that is minus 1. You see here, this is 1, this is minus 1, this is not equal, both are not equal. Even one condition is failure, no need to go for another condition, but you can check for your comfortable. Okay, so now CR equations not satisfied, so that we can say the given function z bar or z star is analytic nowhere. Okay, it is not analytic anywhere. Okay, so that is the example 2. Now you see example 3. Here what is given in the question? The function is f of z, that is 1 over z. We know that z equal to x plus iy. So now check the conjugate for x plus iy, that is x minus iy, then multiply in the numerator and denominator. You simplify it so that you will get x over x square plus y square plus I multiply minus y over x square plus y square. This is the now simplified form of the given function. Okay, now what is u here? Real part of the function f, that this is u. What is v here? Imaginary part of the complex function, that is v. This is v, that is here v. This is v, this is u. Okay, now we have to check the CR equations for analytic. So now what is the first condition? CR equation ux is equal to vy, that is now dou u by dou x, that is now dou u by dou x, dou u by dou x. You find the partial derivative of u with respect to x, that is nothing but, see here, x squared plus y squared minus 2x squared divided by this. So here you can cancel 1x squared. So what is remaining? Y squared minus x squared by x squared plus y squared whole squared. This is dou u by dou x. Similarly, you can find the partial derivative of v with respect to y, that is also minus x squared plus y squared divided by this. So both are equal. So first condition is satisfied. So we have to go for the second condition. What is second condition? Dou u by dou y, that is partial derivative of u with respect to y, and partial derivative of v with respect to x. Here you put 1 minus. Okay, so now both are equal. Second equation also satisfied. Therefore we can say that this function, what is the function? The function 1 over z. This function 1 over z is analytic everywhere except, now you have to see now here you can put any value for z, then definitely it is analytic. We have checked the CR equations also, but if you put z equal to 0, what will happen? You cannot find f of z, means it is not defined for z equal to 0. Therefore see here, CR conditions hold, CR equations are true everywhere except x is equal to 0, y equal to 0, which means at z equal to 0 the function is not analytic. See, that is given here in the diagram also. So diagram is not mandatory to draw the exam, but you can understand easily. See now 1 by z is analytic except at z equal to 0. See, where is analytic? This blue color region. Okay, the function is analytic, 1 over z is analytic, but at which point is not, it is not analytic? At z equal to 0, this is not analytic. Okay, here you can see in the last line, f of z is analytic everywhere except at z equal to 0. Therefore this point is called a singularity point. This point is z equal to 0. Okay, now you see example 4. What is the function? That is f of z is equal to sin z, sin of x plus iy. You can write the rule from the trigonometry, sin a cos b plus cos a sin b. Okay, then you can apply these rules for cos iy. What is the rule? Then you can convert into the hyperbolic. Okay, so now I can write sin z. See, sin z is the given function in the question. Okay, can write sin z. See, sin of x plus iy is equal to, in terms of see, sin x cos hy plus I sin hy cosine x. This is u, this is v, because this is the real part, this is the imaginary part. Now you see here, find the dou u by dou x. See, dou u by dou x, cos x cos hy, dou v by dou y is also same. And second one, dou u by dou y is equal to sin x sin hy is equal to minus dou v by dou x. Actually here what you have to do, you must be familiar with the derivative, with the differentiation roots. Then only you can find the derivatives here. It's very simple. Only two equations. Here equations is nothing but ux is equal to vy and uy is equal to minus vx. See now, uy is equal to here minus vx. Okay, so now here you have to check these two conditions for the analytic. Okay, so now here two conditions are satisfied, therefore we can say that the given function is analytic. Okay, but how to write, see, how to write f dash of z, the derivative of z? Simply, actually we can say simply f dash of z is equal to cosine z. But how we can say? By using this, that is ux means partial derivative of u with respect to x plus I dou v by dou x, that is partial derivative of v with respect to x. You substitute, then you will get this. Okay, actually this is explained in the first slide, how you can write. You see here, the derivative of z is nothing but ux plus ivx. Okay, so we have applied this idea here. Okay, so that we can find f dash of z. Okay, now you see I given here 4 questions to check whether the given functions are analytic or not analytic. Now you see here, the first one, you can try these 4. What is f of z? That is z square plus 2z plus 1. Okay, now put z equal to x plus iy here, then you find u and v, then you check the CR conditions. As we checked the above 4 examples, just you find the partial derivatives and then check the two conditions of CR equations. If both the conditions satisfied, you can write here this function is analytic everywhere. Okay, otherwise not analytic. Okay, for the second question also, second question you can find directly u, v, then you check the conditions. Now for third question also you can find u, v, then directly you can check the conditions. But now you see, what is the fourth question? F of z is equal to e to the power z squared. Here first what you have to do, you substitute z equal to x plus iy in the given function, so that f of z is equal to e to the power z squared, that is e to the power x plus iy whole squared. Here you apply a plus b whole squared, that is a squared plus b squared plus 2ab, so that e to the power x squared minus y squared plus i2xy. Okay, so now what is the final one? See, is equal to e power x squared minus y squared, multiply here, you apply Euler's formula, so that cosine 2xy plus I sin 2xy. Okay, now how to find the real part and imaginary part? What is the real part? That is this value multiplied with this one, that is real part u. What is imaginary part? This value e power x square minus y square multiply with sin 2xy, that is called imaginary part. See here, the problem is not over. We have not checked the condition for analytic. Actually we found u and v. This is the idea I am explaining here. So what you have to do, after finding u and v, you have to find ux, vy, uy, vx, then you check the CR conditions whether two equations are satisfied, then you can confirm whether it is analytic or not analytic. Okay, now you see one important result. See, suppose we know that the function f of that is analytic, then definitely we can say that the derivative, the first derivative of the function is analytic, and second derivative of the function is analytic also. See, third derivative will keep on going. So if f of that is analytic, then the derivatives of the function definitely analytic. Thank you. We will see the continuation of this in the another video.